Welcome to the ThinkGeo webinar. Today we're going to talk about how to build modern GIS apps with the Map Suite WebAPI edition. My name is Clint Batman. I'm the president and co-founder of ThinkGeo, and I'm happy to be with all of you today to show you some neat things to do with the WebAPI edition and building some modern web apps. Before we get started, I want to make everybody aware of the webinar software. You have the ability to ask questions, and we definitely encourage that. So over on your control panel there should be a section where you can ask questions. Our staff will see those, and at the end we're going to have a question and answer session, and we'll do our best we can to get those questions answered. And if I don't know them, we'll try and find somebody in the company that can help out with that. So since we've got a limited time frame here, let's go ahead and get started and dig in. Our agenda for today is to talk about some of the new trends with mobile web application development. It's kind of, what we've seen in the industry over the past couple years and why we built the WebAPI edition. Also wanted to talk a little bit about the WebAPI edition versus some of our previous products, the web and MVC editions, and what's different about them. And then we'll start getting into a lot more technical stuff. Imagine most of you are software developers, so we're definitely going to take a look at some code and talk about WebAPI, REST web services, look at how to wire up the JavaScript to talk with WebAPI, and go through some real world sample code. And finally, I'm going to show you where you can get more help, where you can look at download these samples, and we'll have our question and answer section or session at the end. So lots changed in web app development over the last several years. A lot of it has been driven by the prevalence of mobile devices, phones, tablets, smaller form factors, and a lot of the traditional ways of building web applications just didn't convert well to that. And so now there's this concept of build everything mobile first. It's got to run on the phone. It's got to run on these smaller devices. It has to be quick. These devices aren't as powerful as our desktops used to be. They've got varying screen sizes. And then also the big thing is they need to be touch friendly. So a lot of app design now, instead of having little links to click, you need big, sections to put where you can touch and handle all that. So that created a lot of challenges for building web apps over the last several years. And I think we're to a point now where there's a lot of tools and frameworks that make it a lot easier than it used to be. And so if you're not familiar with some of these frameworks such as Bootstrap or Foundation or Skeleton, they use a mixture of HTML, CSS, media queries, and a bunch of different JavaScript to help you lay out your web app so it can shrink and expand to whatever screen size you're looking to target. And it makes it nice because you can have kind of one set of code that works across all these different devices. Another big trend in web app development is just the, I guess you would say, maturity of JavaScript. And I remember back a long time ago in the early internet, writing JavaScript was a very cumbersome task. It's very difficult to debug. You had a lot of problems between different browsers. And there's been just tons of improvements in that over the last several years by using other frameworks such as jQuery, Angular, and then also the browsers have come a long way of enhancing their developer tools and making JavaScript run a lot faster. So it's really coming of age, and you can do a lot more on the client side, and that works well for a lot of these new modern web apps. So let's talk a little bit about what WebAPI is and why you would use it when building a modern GIS application. So at its core, all it is another ASP.NET framework from Microsoft that easily allows you to build REST-based web services. So if you're not familiar with what a REST-based web service is, think of it as just an API that's over a URL that can handle various HTTP requests. And REST stands for representational state transfer. So one of the things about these types of web services is they're all stateless, but they're very scalable, and they're also self-describing. What do I mean by that? Is since the API is a URL, you're basically hitting an HTTP endpoint. you can kind of understand what the API is doing just by the names and how you set up the URL. And that makes it easier to debug a lot of times, because you can just type it into a browser if you're doing GIS and things of that nature. And you can do cross-platform things as well. So you can, besides just calling it from JavaScript and things of that nature, you could also call it from desktop applications if you wanted to consume these REST-based web services. As you think about it, HTTP is a very simple protocol. There's really only 4 things you can do with HTTP. You can do a GET, a put and a post, and a delete. The way I've seen most of these REST-based web services work is the GET's usually to retrieve data. Makes sense. You're getting something, you want to return data to your client that way. I've seen put and post used interchangeably for both updating data back on your server side and creating new records. And then delete's self-explanatory. Doing an HTTP delete typically is deleting something from your back-end server so the client no longer has access to it. So that's just a real high level of what WebAPI is. It's really just a good framework that Microsoft's built to really easily build these REST web services. And what we're doing here is we're using WebAPI version 2.0, and they made it a lot better where you can do different types of URLs and really build some nice APIs with that. So what are the difference between our 3 different versions of Map Suite targeting the web? Well, our web edition was the first version we ever came out with, and it's your traditional ASP.NET Web Forms development style. So we're going to handle all the JavaScript for you in that case. The control's going to spit out all the JavaScript. It's going to handle that, and it's going to really be more like a desktop type of programming environment that a lot of .NET programmers were used to, and that was Microsoft's kind of first foray into web development. And it's still very popular. The nice thing about that is it is an easy development model, and you can turn things around really quickly. The downsides of it is it's a bit heavy, and it can be difficult to do, the different types of web apps that span across all the different device types. If you're only targeting, browser-based on laptops, it's still a very good option. MVC was kind of the next iteration. This is where mobile phones first started to come into play. And so we did this so people could utilize building different views for, one for phone, one for tablet, one for, your browser-based laptops or desktops. And we still do a lot of the JavaScript for you. It's tied to the old, heavier version of OpenLayers 2.0 that's very rich in functionality, but it's kind of tied to that model of, again, being a heavier type of web application. So a lot of customers were coming to us and they're wanting to do these, lighter weight, very responsive, mobile-friendly types apps. So that's why we built the WebAPI edition. And with it, we give the developer full control over the JavaScript client side. They need to wire up the client side to the server side, but it gives them a lot of flexibility. They can choose, what client-side JavaScript library they want to use, such as Leaflet or OpenLayers, or even other ones if they want. And in some ways, it's a little easier to configure, to scale, and again, it really just comes down to control and can be a little lighter weight application. So that's our different editions of Map Suite and why we were driven to build the WebAPI edition. Okay, so what do I mean by JavaScript mapping library consideration? So with the WebAPI, all you're really getting from ThinkGeo is the components to handle the server side, to do the tile rendering, to do your geospatial type querying, all the things that you've come to know with Map Suite as far as those APIs. From the user interface standpoint is zooming, clicking, things of that nature. There's a lot of great open source mapping JavaScript libraries out there, and the 2 most popular are Leaflet and OpenLayers 3 for these types of new modern web applications. And I just wanted to talk a little bit about the considerations when you're choosing which one to use. So Leaflet is very lightweight. It was built primarily for just phones because at the time OpenLayers 2 was too heavy to be used on phones. And it's a very easy to learn API. So kind of a high level API. You can do the 70% of things you want to do very simple. But once you want to do more complex things, it gets more difficult. They do have a plug-in model for more advanced functionality. So, if you're looking to do projections and drawing and editing, it can be done in Leaflet, but it gets a little more complicated than what it was originally designed for. OpenLayers 3 was a rewrite from OpenLayers 2, and to kind of catch up with Leaflet, I guess, on modern GIS apps to make it more lightweight and to work better on the phones. It's still a more complex API than Leaflet, but it's also more comprehensive. So if you need to do a lot of drawing and editing and projection things in your web application, we typically tell people to work with OpenLayers 3 and just from the get-go, because if you're looking for that more complicated stuff, it's better to just start out with that API. If your applications could be really simple and you know that from the get-go, there's absolutely nothing wrong with Leaflet, and we really like that JavaScript library as well. The great thing about the Web API edition, though, is you can use any library that you want. We've had other customers use like Kendo UI. I know they have a mapping JavaScript library as well. So that's why we built this product, to give you the ultimate choice of how you want to handle your client side. And we just allow you to easily build those back-end services to render tiles and do the different GIS type of operations that you're used to doing. So with that said, let's dig into some code now and a demonstration, and we'll walk through some of these things. And kind of my goals of this is to show you how to wire up the client-side JavaScript mapping libraries to the back-end controllers, how you would go about building your own Web API controller and REST services. And then with that, of course, you're going to want to render tiles. We're going to show how you can also update styling and stuff on the server. Also want to get you a feel, if you haven't seen it, is how nice some of the development tools are in the browser, such as Chrome, and how that interaction works between going from client side to server side from a debugging standpoint. And then one thing that's a little bit different with building these types of applications is, since they're stateless, you have to think about that up front in your APIs, and how do you handle that user state for each specific users. And then finally, with a lot of these applications too, the data transfer back and forth is JSON. So if we've got time, we'll walk through a little bit of that code to show you some examples of how that will work. The reason I chose the basic styling one is it kind of encapsulate all these goals into one sample, and that way we don't have to jump around from sample to sample, and I think it'll be easier to understand, because some of this does get fairly technical, and I want to make it as straightforward as possible. So with that, let's head over to our learning sample. And I'm going to pull this up from Product Center. We have all of our learning samples here under Code Samples section, so you can see where you've got the different products here, and you can click on and you can download these directly from our wiki and load them up in Visual Studio yourself as well. I've already had this one loaded for the sake of time, so let's just bring it up here. And as you can see in Visual Studio, we've got two different projects, one for Leaflet and one for OpenLayers. And we decided to just give samples for both, because the JavaScript can be different between the two. Server side's exactly the same. So they're both using the same REST-based web services to do the same operations. But because these types of applications are so JavaScript heavy, we wanted to give our customers a leg up so they'd have code to use in their own applications. So that's why we provided in for these two. We didn't do all of them because there's tons of different JavaScript libraries out there. These were the two main ones, and so we decided to standardize on them. For this example, we'll just focus on the Leaflet one, and let's just start here, and let me run it, and you can just get a basic overview of what the sample is before we dig into the code. Okay, so this is our learning sample. We're showing different styles, and we've got some predefined styles, area styles, line styles, image point, all the various styles that you would use in Map Suite. The one we're going to focus on mainly is the area style one, and we'll dig into the code on that. But we've structured these learning samples in a way so, hey, you want to look at styling, you can see, hey, here's all the different types of styles that Map Suite supports, and you can really break out the code and look at them accordingly. So if we click on area style here, we're just going to show some basic polygons over our world map kit, and we've got some settings here where we can change the color of those polygons. And it'll go back and update the web API to re-render them as purple instead of brown. So kind of your real basic scenario for building a web app. You've got a base map, you've got some other data you want to pull from the server, you want to style it, a certain way. And of course, you can do all sorts of other things with web API, but I thought this would just be a great sample to get started with. So with that, let's take a look at the code first. And what we have in here is we just have our default HTML page, which is all the markup for the page that handles, the left slide out for the different styles we support, and all the area that we have. And we've added our links to our various JavaScript files up here and CSS files such as leaflet and all of that area. And most of the JavaScript we're going to want to look at is going to be, here's where we reference all of our scripts. And we put most of them in the ThinkGeo script. So that's the one we're going to focus on. So when that HTML page goes to load, it's going to, of course, include this ThinkGeo JS script, which also references leaflet, and we've got a few other in jQuery too. So a lot of the common JavaScript frameworks that you'd be expected to see. So we just got some initialization code here for our color picker that we used in the sample. And here's where we initialize leaflet. Leaflet's used with a capital L, and then .map is to reference the map control that we had defined back in the HTML. And we're setting the view to a certain extent and zoom level 4. So that's basic leaflet code for setting that map. Here's just some image buttons for the user controls. We add them to the map as well. And then this section here we're doing where we're adding the world map kit as our base map. So a lot of these samples too, we wanted to give it some context, so we just use the world map kit as our base map. Our selected layers, predefined styles, so that's the first one we had in the list there, so we defaulted to that. And then here's an important part as well. So this is where we start to consider user state. So for each session of the web page that comes up, we create a new GUID, and we'll pass this access ID to the server so we know when it comes in who's requesting it, because maybe they changed some of the styling, etc. And we've got to look up what their styling options are to return the right the right rendering of what they're asking for. So that's the first thing to kind of keep in mind when you're building these type of applications is you have to know how your user are. Now you may have a security system where you already have your user authenticated, things of that nature that you would pass in instead of just using a GUID, but we did it this way to keep it simple for demonstration purposes. Here's where a lot of the magic happens, where we're actually calling the web API. So we're creating a new dynamic layer with leaflet. We're just getting the root path so we know, it's localhost, whatever my port number is for my local development machine. And then this is the URL or REST service for where we're looking for our URL endpoint. And of course, we're passing in that access ID I just talked about and adding that layer to the map. So, you can see we've got basic styling, which was our layer name. Predefined styles was the first type of style we wanted. And then leaflet and both open layers are pretty much all these JavaScript clients do this ZXY format. So you don't have to worry about, well, how do I know how to pass the tile coordinates into the web API? That's all handled by you by either open layers or leaflet. Really all you got to do is tell leaflet is what URL you want to go fetch those tiles from, and it will pass all the Z, X, and Y in there through this parameter mapping or parameter or URL templating. So that's that's the first REST URL we'll take a look at, a REST service look at, is how to build the tiles. So that's it on the client side code. Let's take a look over here on the server side code. So we typically put all of our web API, the REST web service underneath controllers. And if we look at base styling controller here, we'll scroll up to the top and you can see, we've got a route prefix for basic styling. So that's saying anything under this controller is going to have the URL with the / base styling. And then we've got another one which says, get dynamic layer tile. And we're giving the route for that as well. So it could be the style ID. So in the one where we saw in the sample, we were passing in predefined styles, but as we click through those ones on the left, it would be area style or point style, etc. So that's getting passed in as a parameter. The Z, X, and Y that we were talking about, for the location of the tile, so the server knows where to render it. And then also that access ID to pass in who did it. So that, and you can also see we're only accepting HTTP GET requests on this. So from your client side code, I know Leaflet's doing it in this case, but they need to be doing GETs in order for this web service to work. And of course, Leaflet and OpenLayers both do that when they're requesting tiles. We'll talk about doing posts for updating and that a little bit later on. So what happens is it then gets called and in here passes all these things in. And let's just put a breakpoint here. Let's see if we can get it to so I can show you how this is working a little bit. So if I just zoom in one, you can see now that we've hit our breakpoint. So Leaflet has made that call to that URL. We've got our style ID of area style, our Z of 18, our X of some number, and our Y of number. And then this access ID, of course, is the unique GUID for me in my browser instance right now. Once we come into these tiles, we've encapsulated this a little bit, but we have our layer overlay where we go and get our styles. So let's just go in and let's just step into this and you can see how it all works. So here we just got a case statement for the different types of styles we're showing in this sample. And so we're going to go through our area style and get that, again, passing the style ID and the access ID. If we go into this definition, you can see we're just loading up our shapefile. It's a shapefile feature layer. So if you're an existing Map Suite customer, all this code should look very familiar to you. Loading up that shape, giving it our styles accordingly, and then we're also checking to say, hey, did this user change any styles, and if so, we're applying it and returning that all back. So let me go ahead and run this through. The other important part is this is where we actually draw the tile. So we build up our map or what we're wanting to render in the tiles in this layer overlay, and then we're passing that into the draw tile image. And so if we go take a look at that code, it's going to take that layer overlay and actually create a bitmap or a PNG that will get returned. Let me go ahead and let that run here. A 256 by 256 tile using the geo canvas and drawing on there. So this is what's actually building the tile and then returning the PNG back. So each one of these GET requests is returning a PNG and drawing those tiles accordingly. So that's what's nice about this, is it's all very stateless. You just hammer the server with those URL requests and it will bring back those tiles accordingly. And if we want to take a little bit closer look at, of what's happening, let me bring up the Google developer tools. Let me just zoom in here or zoom out one. And you can see all the requests getting made to the server to bring back the tiles here and all the PNGs getting done. So there's our URL that's being created. Let me make this a little bigger so you can see it. So that's our REST service that's grabbing that tile. It's calling, the local host here on my development server. passing in all the parameters, area style, X, Y, Z, and then the GUID to return all them back to Leaflet. So that's really neat for doing tile rendering. So let's talk about how you do some other things. So tile rendering is what most people, or a lot of people, do to at least get started, because they have a lot of data on their server. They want to overlay it on their base maps and render it in a fashion that they see fit. And let's take a look also at the JavaScript of how all that's set up. So I'm going to come over here and go to our source, and let's look at the ThinkGeo JS. Just to reiterate, because sometimes this gets a little confusing going back and forth to the other, the two ones. So here's where we're setting up our dynamic tile, or our dynamic layer for our URL that's going to the controller we just looked at to return the tiles. And just so you can see how the sample's actually working, again, if I switch between one of these, so for example, if I go to point styles, when it makes that request to the server, it's going to pass in point style instead of area style. So we're just in the JavaScript, as you click through these various things on the left, it's switching the style ID that it's passing to the server, so the server knows how to handle it. So you can really have a tight relationship between your client and server and build your REST web API or your REST web services for your exact needs. Now, the other reason I picked this sample is because it's one of the nice ones that shows, all right, so let's think I'm building a web application here and I want to have certain configuration for each user. And how do I handle that? So this is a good one, because a lot of times what people want to do is they want to give their users control over how to style all their functions accordingly. So how are we doing this with Web API? Because it's a little bit different than how you would do it with most applications or development types. So for example, if I want to color this tile as yellow and save that, what's going on behind the scenes? So let's take a look at that so you can understand. So that's this next part of the JavaScript here, is where we're loading the style editing page. So we've got that pop-up that you've seen in the on the sample. And what we're doing here is we're again getting a URL, and we're going to call the get style REST web service this time with the selected layer and again our access ID. And then depending upon what sample we're in, we're going to get back some JSON from the server and then populate our UI accordingly. So here we're just getting that URL, and then we have right here we're doing our get. So we're using the jQuery get, passing in that URL. When that function returns, we pass that data into this area where again we're using jQuery to fill out that user interface. So let's just show you how that's working as well. Let me put a breakpoint on this, and let's put a breakpoint over here. And you can see here we've got our get style. It's our public method for get styles. So let's put a breakpoint there. And now as soon as I click this little settings gear, it's going to make a call here to the JavaScript. You can see I've got my breakpoint set here. If I do, what is it? That's going to get the path. So if we hover over this URL now, I don't know if you can see that on the webinar or not, but it basically is pointing to the basic styling get style web API. I'm going to go ahead and let this run. Now we should hit our breakpoint on the server side, and you can see we're getting passed in the area style again, that same GUID representing my browser instance. And here's where we're going to go through and create some JSON by getting the current style that the user has selected and returning it in a JSON document. So this is what's actually going to be returned back to the server. This just basically name value pair, a little JSON document. And then that gets returned here and fills out all of the given text boxes for this user interface. It's kind of just the opposite of that for actually updating back on the server. So for example, if I want to change the transparency here to 100 and I hit save, that's going to then call, it's going to do a post. I think that's bound here. Yeah, so when we hit the save, we check to see, oh, what style it was. We load up back from the UI the different values that the user selected, and then we post to the URL for calling an update style, and we're passing in that parameter there. And you can see we're using a JSON, or not a JSON, a jQuery post to that URL, and then we're stringifying that JSON document to then get passed. So if we look back over on the server here, we've got another web API for updating the styles. And you can tell here that it is for, it's going to be a post because it's coming from the body. So the post data is going to come in here, then we convert, deserialize it from JSON back to our name value pair of styles, and then we update that layer style on the server side so we know how to render the tiles correctly and send them back. So that's a good, I guess, a good walkthrough of how you would go about building these things. So it's a little bit different. Like I said before, you got to worry about the access ID to know who's updating what. You know, in this sample, we're just saving it to a file, but in a real world example, you'd probably be saving it to your backend database to keep those user settings correct. But it is a powerful way for you to build these kind of simple web service APIs to do a lot of functionality that both your web app can use and even other applications can use. I mean, you could do this from a native mobile app as well, because the nice thing about being a REST web service is you can call it from anywhere. So with that said, let's see, what do we have next here? And I might have mentioned this already, but all this code is free for you to download and play with. The best way to get it is through Product Center. You can click on the Launch Sample button, and we were doing the basic styles here, and that will download the solution, and you can run it in Visual Studio and debug it just like we did here. Now, if you're new to Map Suite and you're not sure about all the other capabilities it can do, we've tried to build a learning sample for virtually all the different capabilities of Map Suite. So as you can see here, we've got a getting started one. That's really just kind of getting you used to the different JavaScript libraries, how to do things like a GPS locate, handle the map click events, some basic pop-ups, real simple stuff. Then we show you how to do some labeling. You know, that's real important in a lot of GIS applications. You might have custom labeling types of requirements, and then visualization too. So that's taking it to the next level over basic styles. So we have all of our styling apparatus available to you in WebAPI that you would expect from all of our other Map Suite products. So you can do custom styles, you can do ISO lines, heat maps, etc. In addition, we got geometric functions, so all of the things are there for doing buffering, unioning, difference calculations. You know, again, all the things you would want in a GIS suite, and drawing and editing as well. So Leaflet, we give both. That's using one of the plugins. That's one thing to be aware of with Leaflet, the drawing and editing. We are using a plugin for that. The open layers, I think, is using the native drawing and editing for it. And I won't go through all of these, but you can see the wide variety of functionality that we provide samples for. And we're always adding to this list too. So check back through Product Center. That's the best way, because as soon as a new one comes out, it will load in through this code sample section, and you can see it and just launch it directly within there. Okay, let's talk a little bit more about where you can get some help when you go to build these applications too. So let me pop back to the presentation here. So as you start to build your Web API application, where can you find help and answers to your questions? Because you're probably going to have a lot of them. I know we have a very active discussion forum out there, and that's probably where most of our people go for questions. But certainly if you don't want it to be in a public forum, we also have our ThinkGeo customer portal where you can ask and enter tickets, and we have a development staff there waiting to help you out. We already talked a little bit about Product Center where you can download the samples and templates, so that's a great resource. I know for me, I like to actually step through the code, see it, debug it. That's how I learn the best, but and take codes pieces out to build up my application. All that's tied in with the wiki too. You may have noticed with the Web API, we did a little bit differently. We tried to focus on 12 to 14 samples for each specific area, such as labeling or geometric functions, where in a lot of our other products, we had a how do I samples where it was kind of really code snippets together. So we tried to make the samples for the Web API a little more comprehensive so you could take pieces of those out and actually use in your application, as well as we built some project templates so you can maybe even start with for building your projects. And then finally, if you can't get the answers to your questions through the forums, or maybe a little bit more than your typical support or technical type of question, we also do offer professional services where we can help with architecture, we can help with building your solution up. It's become a big part of our business over the last few years. And just while I'm thinking about it too, just as we went through here on Leaflet, the same exact JavaScript and controller code is available also for OpenLayer. So we give you both of those. So depending on whichever JavaScript library you pick, you got a real head start to using them. All right, with that said, I think it's time to open it up for some questions here. It looks like we've had several come in, and I'll see if I can do my best to answer these, and then we'll wrap it up for the day. So, all right. So it looks like we've had a lot of questions from Caesar. And he was asking, is this example for WGS 1984? Actually, the example I showed you was not. It was in spherical Mercator. It was the same projection as you would use for Google Maps or Bing Maps, those types. You certainly can do it in WGS 84 if you'd like. If we want to take a look, I believe we are reprojecting these to that. I know in one of our samples we're actually reprojecting it, but we probably in this one our shapefile's already in that proper projection, so we didn't have to reproject it. But a lot of the samples are in WGS 84 and they're reprojecting it to match the base maps of World Map Kit or Spherical Mercator. If you are wanting to do just straight WGS 84 and not have a base map, I would recommend doing the using OpenLayers 3 because it's going to give you more flexibility on that. All right, so I think that answers that question. All right, we have another question here is, can you do this to make a hybrid solution? And yes, certainly you can. You can mix and match all of our different raster layers available. If we go look, I mean, the sample I showed you today was just using a shapefile. But if you come here to our layer sample, you can see we support a wide variety of different formats: shapefile tab, TinyGeo, file geodatabase, and so on. In addition to the vector formats, we also support the raster formats. So this is where you can mix and match and do a hybrid solution of having an aerial photo with overlaying your vector map on top of it. And so you can probably, if you want to see a hybrid solution, I'd take a look at that layers one because that shows you exactly do that. Also, this sample shows different other places you can get data from. For example, we have the NOAA radar, which is pulling from a web service that shows the radar over the United States. So the answer to that question would definitely be a yes. Let's see. If you have any other questions, please feel free to ask them here. We'll use the remaining time to get those answered. Okay, we got a question here from Yuri about what is the real code that we have to do for the example that you showed. All right, so good question, Yuri. And I guess it all depends on some degree, but you definitely have to write all the controller code. So that's all of the C# controller code to render your tiles, handle your updates and things of that nature. On the client side, really all these JavaScript libraries like Leaflet and all them you just include in your project because that's handling the JavaScript mapping API. And then you will need to write some client code to handle your interactions between your user interface and then setting up Leaflet to call your web APIs. So pretty much the code you're going to have to write for your application is going to be what's in this ThinkGeo.js file. Now, granted, you can copy a lot of it and just modify it for what you want. All of the controller code, and then of course the layout that you want for your HTML page and tying it all together. So you've got your markup, your client-side JavaScript code, and then your controller C# code. So I hope that answers your question. Let's see what else we have coming in here. All right, is the API available for mobile systems? If I'm understanding that question correctly, I would say the answer is yes. So this is just a REST API, so anything can talk to it via URL. So even if you're building a native mobile app, you can still build your backend web services using the web API to send down those tiles and that sort of thing. Now, you won't be able to use Leaflet or OpenLayers potentially in there because you'll want to use a native type mapping library like our Android or our iOS system to consume those tiles because there's still going to have to be code that will make those requests, handle the panning and zooming and that sort of nature. But yes, this can be called from virtually anything. It can be called from your web app, your mobile app, desktop applications, anything that's got accessibility to that URL and that can handle the response back. So it's a very lightweight type of protocol for serving up this type of information. All right, if anybody else has any more questions, please feel free to add them here and I can answer them. Another question about base maps, and it's probably one thing to talk a little bit about as well that I didn't probably explain enough. So, like for example, on our styles here, let me go back to the other one. We're using a base map of the world map kit that's pulling in, and that's all. This one actually isn't, but the way a lot of these are built, if you have your base maps, such as our world map kit, our Google Maps or Bing Maps that you're going to want in your application, and you can pull them just directly client side because like our world map kit or Google Maps, all of them have servers built up where the tiles are pre-generated, and for the the most optimal performance, you're just pulling those already built JPEGs down across. And so Leaflet, OpenLayers, all them JavaScript libraries can pull them all natively without even building any REST web APIs. The problem comes in is when you want to change the tiles or you want to add a lot of data on top of those, you want to do the types of functionality that we were talking about as far as, you know, geometric functions, distance queries, etc., then you're going to have to build your own REST-based web services to do that. So typically what we see is people have a base map, and they handle all that client side. So that could be our World Map Kit, Google Maps, Bing, etc. And that's one layer that you set up in your JavaScript library, and then you use your REST services to overlay on top of that any other tiles you want to render. It doesn't have to be that way though. You can render your whole entire base map all server side through WebAPI and send them down too, and there's nothing wrong with that either. Just a lot of people like to leverage the already existing base maps, but if you don't want those, you don't want all that information, you want to control every aspect of the map, then you would set up, you know, the different formats we were talking and build your map up accordingly and just render those tiles down to your client. So I hope that answers that question. Let's see if we got any more questions here before we wrap it up for the day. Okay, we've got another question here. From the user perspective, what is the difference you can see from the different versions of Map Suite? So the Web Edition versus MVC and the Web API. So that's a great question. So on whole, the Web Edition is probably going to be a little slower because it has to generate all the JavaScript every time. It does postbacks, it does view state, so it's a lot heavier of a page. It's not noticeable. Probably if you're on, you know, a desktop type environment, you've got a fast internet connection, and you know everything's running smooth. But if you're on a mobile device that maybe doesn't have that much processing power, and maybe the network connection's a little slow because you're going over cellular, then things can bog down a little bit. So that's the one end of the spectrum. Like the Web Edition is going to be your heaviest type of implementation because it handles everything. It spits out all the JavaScript code. You know, it's kind of the black box of mapping where you do everything, and it kicks out all the client code. And with that, there's some trade-offs. This on the other side is, the Web API on the other side is the lightest weight. So you have complete control over the client and exactly what you push down to it in different scenarios. You know, so if you're using, you know, Bootstrap or some of them other frameworks, it's going to know, hey, he's on a phone. We're not going to do these. We're not going to do these other type of operations. And the other advantage is all the JavaScript can be cached because like the leaflet JS and those things never change, and just the JavaScript that you're modifying changes. So I'd say on average, the Web API is going to be more responsive. It's going to be probably a little more difficult to develop, where the Web Forms or Web Edition is going to be easier to develop, but it's going to be a little slower, a more legacy type of feel from a user experience. Great question. See any other questions came in here? I think we had a question from Frank. Can you use Google Map or Bing Maps as the base map? Absolutely, Frank. You can use, you know, Leaflet. OpenLayers 3 has built-in support for consuming Google Maps, Bing Maps, OpenStreetMap, our World Map Kit, any WMS type of base map as well. So you've got full control to pick whatever base map you want, and or build your own through the rendering of tiles. So lots of options there. Okay, looks like we've got a few other questions starting to roll in here. That's great. Keep the questions coming. If I can just get the questions that I haven't answered yet to come up. All right, here's another good question. I'm not very familiar with the Web Edition, but it seems the classes used are the same. Is it possible to use the server-side classes of the web edition in combination with some client-side code to mimic what the web API edition does? Yeah, you definitely can. You could just use the core, not so much the web edition, and build your own REST services around that. But you're going to be missing some key API to make it easy. We've built in the web edition the layer overlay and a lot of APIs to handle going from the XYZ type of mechanism to generate your tiles. And so while it's technically possible to do with our other editions, it becomes a bit cumbersome because you're going to have to handle a lot of lower level code for lining all this stuff up and handling it down. So the Web API edition is a light piece of functionality on top of our core to make it easy for you to handle these types of requests. For that, we've got like our Web API extender helpers and that, so they're specifically designed for these types of scenarios where the web edition was not. It's designed for dragging the control on there and doing the more web form type of development. Okay, great question. Okay, we have another question here. My client needs to make the route made by their truck. Is there a way to implement this and have a back end? I'm not sure I understand the question completely, but we do have a routing engine plugin, so you can build routes, to show where your truck needs to drive, if that's the way I'm understanding it. If not, if you've got a GPS trace of where they're, certainly you can build a back end to display that if you're querying those points from a database and you want to display that over the map, so that can be helpful as well. Okay, here's another great question. I think we hit on it a little bit, but just very briefly. If you have to deal with different coordinate systems, how would you do this? Would you make the conversion in the controller code in C# or make the conversion using open layers or leaflet? All right, so if you're doing leaflet, I wouldn't do any conversion there. I just leave it in its native projection and do everything server side. I'd probably do that for both open layers and leaflet because we've got a robust reprojection engine on the server side, and plus you have more processing power there and the APIs are a lot more robust. So typically in the applications I'm building, I do all of that conversion on the server side using our projection library. And a lot of our samples show that. This one doesn't because we already had our source data in the same projection, but if you look at the other learning samples and do a search for projection, you'll see where we do those conversions on the fly on the server. But a great question. How to get driving distance from point A to point B, that would be using our routing engine. So in there you can definitely get routes for driving from different locations. And we recently built a tool to where we can take our world map kit data and build some routing indexes for anywhere in the world. So contact Moritz or at sales@thinkgeo.com if you have any questions on that, and you can provide some insight. Let's see here. I think we're getting through most of the questions. I don't want to miss any. We only got a few minutes left here. Okay, here's another question from Frank. Comparing with the Map Suite Xamarin version with the Web API edition, which one would you recommend? So they serve two different purposes, Frank. So the Xamarin or our Android and iOS editions, which use Xamarin, are used for building native apps. So they're kind of more along the lines of what you'd expect with like our WPF edition or our WinForms edition. And so with that, you get the tools to build the rich client, offline type of scenarios to some degree, and where it's a control, you drop on the form on there. The Web API is built specifically for building REST services. So you could call the REST services from the Android and iOS editions as well if you wanted to standardize on that across your different platforms. If you had an app, say, for Android, iOS that were native, and you also had a web app and you didn't want to duplicate the server-side code, you could use the Web API edition to build the back-end REST services, and all three of those could then consume from the Web API. But you're still going to need the Xamarin Android and iOS editions to build those native applications for those platforms to handle the user control and the user experience in those native platforms. This is the web, the Web API edition is just going to be the server side for REST-based services. All right. Let's see if there's any other questions here, and if not, we're going to go ahead and end the webinar. Also, we'll make this recording available and the presentation and everything available up on the website so you can take a look at it at your leisure, because I know a lot of people probably couldn't stay for the entire thing and may want to come back and review some of the code as well. So. Here we got a question from Chad. What are the differences in pricing levels as far as what is included with each package of WebAPI? Looks like there's 6 different options on your website. Chad, I'm probably not the best person to answer that. Maritz would probably be a lot better. I know we've got a product wizard out there that'll step you through the various options. So we've got both subscription options and perpetual licensing options. So that would probably be the best place to look. And he can also, Maritz at sales@thinkgeo.com can also help you out with any questions on that. So I think that's our last question. If there were any I missed or didn't address, we'll try and follow up with you and get those answered. Thank you again for taking the time to attend today, and we hope this has been helpful. There'll be a short little survey at the end of this. And please give us your feedback if you'd like to see more of these or what we could do better to make these webinars more productive. Thank you very much.